welcome back to the channel. It's been a little bit since I've recorded a video. I apologize for that. Um, had a lot of studying to do, but I've also had I don't know, I've just been having a really tough time trying to find a good software to record and edit these on. So finally got that squared away. So I'm back and hopefully I can record a little bit more regularly. But yeah, without further ado, we're just gonna jump right into it. So tonight we're gonna deviate a little bit from the foils and talk about icing. We're going to go into weather. So icing, that's the topic of the discussion for tonight. And so, yeah, without further ado, let's just dive right into it. So, what is icing? The FAA describes icing or defines icing as ice accumulation that forms on an aircraft's wings and surfaces, either in flight or on the ground. So, in order for icing to occur, you need two ingredients. You need visible moisture and you need the temperature to be near freezing. And near freezing is actually kind of more of a range. So it can be, you know, 3 degrees Celsius all the way down to negative 30 degrees Celsius. So visible moisture and temperatures near freezing. So when we talk about icing, we kind of categorize it and talk about it in two different ways. The first way is where. Where is the ice forming? Um, so kind of breaking that down a little bit, it's forming on our instruments. So like the pitot tube, for example, is it forming, is it structural icings? Is it forming on the leading edges of the airplane or the wings or the prop? Um, or is it induction icing? Is it forming in the carburetor or in the air filter? So instrument, structural icing, and induction icing. The next way to categorize it is how, or meteorologically, how is it forming? What kind of ice is it? And those are three different kinds of icing. That's clear ice, rime ice, and mixed ice. Um, so yeah, kind of going back to structural icing or icing in general, in order for it to even form, we need to have what's called a supercooled water droplet. And what that is a water droplet that stays in liquid form even if the temperature is below freezing. And when you do encounter icing, it's first gonna really show up on areas of the plane that have the smallest radius, and this comes from advisory circular 9174, which I'll link below. But yeah, ice forms on the smallest surfaces or smallest radiuses. So, like the prop, and then the leading edges of the airplane, and then the empennage and the wings and stuff. So, um, diving in a little bit more, we've got the three types of this aircraft icing: clear, rime, and mixed. Like I said before. So clear icing, what is it? It's icing that forms between 2 degrees Celsius and negative 10 degrees Celsius. And when it starts to form, it appears clear and smooth, translucent. Think of you know think of an ice rink after a Zamboni is driven through it. It looks like that. It's that clear, and kind of what gives it that clear look is that's actually air that's being trapped uh, inside the droplet as it's freezing. Um, So it tends to usually kind of form, when it does form and accumulate, it tends to form these a little bit more complex shapes on the plane, and it disrupts airflow. The next one is rime ice, and that forms between negative 10 and negative 15 degrees Celsius. And that's a little bit more rough. It's opaque. It's, think of a snowball, if you will, what that looks like. That's kind of more of what this, or like fresh snowfall on like a railing or on like stairs outside or on your car. That's a better way to think about what it looks like. So they tend to form in kind of these more like wedge shapes. And what's happening here is these supercooled water droplets. Now they're forming on contact. Before with clear ice, they weren't immediately forming on contact with the surface. Now with the rime ice, immediately upon touching the wing, if you will, or the surface of the airplane, it's going to freeze. The last kind of icing is mixed icing, and that forms between negative 15 and negative 20 degrees Celsius. And that's, as the name suggests, a combination of clear and rime ice. And that it forms rapidly when these particles are becoming embedded inside the clear ice, and it's very rough, kind of a jagged um, accumulation. In this situation, there's a lot of air that's being trapped inside the ice ball. So we've got clear, rime, and mix. Those are the three types of aircraft icing. Why is this even important? Why do we need to know this? Well, you have to know this for your check rides, but also it's important in real world flying because it has an effect on the four forces of flight. It affects the airplane dramatically when it does accumulate. So this is a graphic of a 172 in straight and level unaccelerated flight. And in this condition, all four forces of flight are not disturbed and they're in equilibrium. So we've got lift, weight, thrust, and drag. When ice starts to form, all four forces are affected almost simultaneously. When ice accumulates, you'll see an increase in drag, a decrease in thrust, you'll see an increase in weight and a decrease in lift. The airplane becomes heavy, loses engine power, becomes much harder to control. Um, Even if it's just a little bit of icing. And think of like a piece of sandpaper. A piece of sandpaper, not very thick. A ice as thick as a piece of sandpaper can cause a reduction in lift by 30%, and it can increase drag by 40%. So when you think about that, that is why this is so dangerous. It only gets worse from there. Um, so that's why this is important. Important. That's why we need to know about it. So how do we even know if ice is forming? Well, there's a couple different ways. We can look outside. It might not look like this. This is pretty dramatic. Um, but yeah, usually, we can start to tell if ice is forming if we just look outside, like in a 172. If you look out the left window, you'll see the pitot tube. And if it's not, the pitot heat isn't on, and you see ice starting to form, you'll see ice starting to form on it. Um, it also you'll see it starting to form on the wings. Um, the outside air temperature probe is another spot to you'll see it. Um, and then actually on just the outer surfaces, not surfaces, but like the outer edges of the windscreen and the windows. Um, so those are all kind of the places you can look if you start to suspect icing. Another kind of indication of icing is if you notice the airplane just gets it's a little bit harder to control, or it feels a little, I guess, slushy with some of uh, the elevator or the like the yoke. Um, so those are a couple ways to know if you are picking up ice. Lastly, hopefully, if that's your goal, we'll move on to more advanced aircraft. More advanced airplanes, they tend to have de-icing and anti-icing systems. Um, so let's kind of talk about those. So when a de-icing system, that is when you're removing ice that is already on the airplane, and that can be done a few different ways. One is like a de-icing fluid, a TKS fluid. One's a pneumatic boot, and the other is an electrical thermal system. So kind of going back to the top where that de-icing fluid comes into play. Some airplanes have what's called a weeping wing system. So it's controlled by a switch in the flight deck that the pilots can press. And what that does, it sprays this de-icing fluid, this glycol, um, all over the surfaces of the airplane, and then it melts off the ice. Another way is a pneumatic boot, something like this, or like this. So what this pneumatic boot does is when it's activated, again, it's activated by a switch that the pilot controls. Um, it uses engine bleed air, and what that does is it heats up and inflates the boot. So this ice on, this ice that's built up, once the air, once the system's activated, it'll start knocking the ice off. Here's another example of that. These will inflate or continue to inflate, and it'll start to knock the ice off. Lastly, there, whoops, I'm kind of going all over the place. Lastly is like the electrothermal system. So that is like a heating pad that's on a prop. So this photo here, these kind of like almost they look like pieces of tape. Um, but they're installed on the prop, and what they do is controlled again by the pilots on a switch in the flight deck. You flip the switch on, it starts a cycle that goes on and off, and heats the surface up, which allows for ice to melt. The next side of things is the anti-icing system. So that is how that's different from de-ice. Remember, de-ice removes the ice, anti-ice prevents the ice altogether. Um, so there are, again, just like before, three systems. You've got a bleed air system, an electrical way to to get rid of the ice, or to prevent the ice, excuse me, and then anti-icing fluids. So a bleed air system, that's kind of more common on, say, like a jet, a big old turbine engine. So what that does is it uses this hot compressed air from the compression stage um, to be able to heat the edge of the wings and the airfoils, allowing for um, ice to uh, ice to not build up. So it prevents it from building up. Um, the next way is like an electrical heating type system. So that's going back to the 172 or Archer. That's flipping the pitot switch on and the pitot mast heats up, or the pitot tube heats up. Lastly is like an anti-icing fluid. So again, you can take a TKS fluid or a glycol, um, and that's just actually like spraying it on the wings of the airplane. And I've seen this done at the airport before, usually in the morning, like when there's a little frost buildup. Um, I've seen line guys go out there and they'll spray the wings to get to prevent ice from building up. So yeah, that is pretty much it. So we kind of just discussed these three. We discussed the three different types of icing, a little bit um, how to detect it in flight if you think you might be picking up ice, and then just some anti-ice and de-icing systems. Um, oh, lastly, we need to if you encounter icing and if you end up in a situation where you fly into icing you didn't know, um, what do you do there? So quickly here, um, if you do find yourself in that situation, if you can, whip a 180. It's a little bit harder here because ice, again, how it affects the airplane, it can dramatically decrease the airplane's performance. Um, so, what do you do? Like I said, when we whip that 180, actually, the first thing you would do is throw the pitot heat on if it's not already on, and then change your course. That's turning around, that's descending, that's climbing, and then lastly, turn that cabin heat on. So, um, yeah, why would we descend? Well, usually if you get into the cloud like that, if they aren't that low, you can maybe get below the clouds, but you run the risk of getting closer to terrain if you do that. But usually that's preferred over climbing, because if you try to climb, you could well, a couple of things. If you try climbing, you might not know where the tops are, which while you're in the climb, you could accumulate more ice, which would be make the situation more dangerous. And then even when you do get up top, you might not know where your next opening is in the clouds, and then even then you would have to descend back through the icing potentially. So usually descending is preferred over climbing generally. Um, and then, like I said before, just turn around, but you got to be careful doing that, because as you're in the turn, you're going to also accumulate ice. So usually, kind of a rule of thumb in this scenario too is you're doing half standard rate or less. It's just gradual. You don't want to be too um, dramatic on the controls, if you will, in this situation. So now I think I've covered everything. I keep looking down. I got some notes here for how I was going to cover the lesson. So yeah, that's just kind of a brief overview on icing. I'll link some sources for some more um, in-depth reading about the subject. And of course, like I'm looking forward to, let me know if I missed anything, or if you wanted me to go more into detail on something, or if I made a mistake or something, because that's important too. So yeah, I hope this helped, and yeah. Hopefully, I'll see you all soon. Bye bye.